Okay, so hello again. Now, what we're going to look at in this video then is going to be the an energy analysis, i.e. the PV Sol outputs that we're going to add into this quote. What you have here, again, we're just going to focus on this one single section here now. So it's an energy analysis brackets PV Sol. That's the important bit here. Now what you'll notice, first thing you'll notice is there are a series of red flashes, which means there are a series of mandatory fields. And again, without those mandatory fields being completed, you will not be able to progress this quote to completion and save it, because it will throw up an error and say you haven't completed them. So we're gonna do that now. So again, this is coming from the PV Sol, okay. Or if you don't have it from the PV Sol, you can estimate it by some other means, but of course the customer has to know that, and that's fine in illustration because it is just an illustration, but the customer has to know that the figures that you are throwing up at them are genuinely just estimated, and they've not been kind of built in any way by PV Sol. You can also put zeros in if you wanted to get past the mandatory fields. This you'd put a 0 in, and that would be fine because, for example, you might be doing a tender where there's absolutely no energy analysis on it because you've not even properly done one, and you can add that as a 0. That will reflect later in the documentation that you're producing for the tender. But anyway, those are the options. So PV generator energy, the kilowatt hours per year. Okay, you know what it is. That's the figure about the kilowatt size of the system times about 850 to 950, whatever it is, kilowatt hours per year, and that's the number that goes in there. You do not need to add quotes. So because I've chosen a 250 kilowatt system, I'm going to get my calculator out now, and I'm going to assume it's 900. So I'm going to go 250,000 times 900 equals, and then divide that by 1,000 because I don't want the number to be too ridiculous. It's 225,000. So I'm just going to go 225,000. Okay, and that's what the yield is for the whole system for a year. Then you've got the specific annual yield, so the number of kilowatts per kilowatt hours per kilowatt, effectively. And on this one again, you remember I chose 900, so I'm going to stick 900 in there. I need to put a yield reduction due to shading. So again, I don't believe this is a percentage field. I think this is using the shade factor number that's quite popular within PV Sol. So for example, if there is no shading whatsoever, then the shading factor is 1.0. Okay. If there is 100% shading, why would you ever do it? Then the shading factor is 0, and effectively for every percentage of shading, you would reduce the shading factor. So you start off with 1. Okay, it's got, say, 10% shading, then that's going to be 0.9. So in this situation, I'm going to put in 1 just for ease of calculation, but that's worth watching. That if the yield reduction due to shading that comes out of PV Sol is different than that, is expressed differently, you should have an awareness of that. You're looking for figures which are less than 1.0 rather than a percentage. So here I'm going to say there's no shading at all, so I'm going to go 1.0. Okay, then you've got own power consumption. That's a percentage figure. Okay, now the PV Sol will suggest what that own power consumption is if it's done its analysis, but if it hasn't, then you are going to choose a figure of, I don't know, whatever. I guess the MCS approach to this is usually, say, 50%, something like that. You may think it's more because they have a higher archetype. A lot more of their power will get used during the day, or a lot more of their power is going to get, a lot less of their power, sorry, is going to get used during the day. They're going to be exporting most of it. Then a different archetype you use as a percentage. But I'm going to just stick in 50% here. Now, you'll know what self-sufficiency means, and the PV Sol will tell you what self-sufficiency means based on that. Again, I don't know what that figure is, so I'm just going to guess it to be 50%, but who knows what that is. Then you've got total consumption, so that's the total consumption of the electricity in the year. In this case, again, I don't know what that figure is. You'll probably laugh at me when I write this number in, but I'm going to put in there that there are, let's say, 100,000 kilowatt hours in use per year, and of that, because we think that 50% of it is own power consumption, that's going to be 50,000 of it is then going to be covered by PV in the year. Then covered by grid is going to be 50,000 as well. Okay, following me? That would all change very differently if there was a battery involved. Of course it would. So that's why batteries are kind of excluded at this stage from these calculations, and it's also why we're not going to rely on these. We're not going to rely on these in order to in order to create these. We're going to rely on what comes out of a PV sol. CO2 emissions avoided. So again, there are varying different figures on this. The one I think that we're using at the moment is something like 0.19 kilograms, 0.19 kilograms per kilowatt hour. So if I was to say that we've got 100,000, sorry, it's using 50,000 of it during the year, so we're going to say 50,000, and then we're going to multiply that by 0.9. Okay, so that's 45,000 kilograms. So I tell you what I'm going to put in here. I'm going to put 45,000 kilograms. Again, it's a mandatory field. Something has to go in there. And the electricity price, I don't know what that is. It differs obviously from customer to customer, but I'm going to choose 0.3 at that point. Again, it's pounds, not pence. So don't put in 30 pence. Put in 0.3 pounds. Okay, that's really quite important. So there we have the energy analysis section, which is created from PV sol. You either make it up, but the customer needs to know you've made it up, or you just put any old figures in there to get past this. And again, that gets explained to the customer in your dealings with the customer to say, listen, I'm unable to create this energy analysis for you, so I've just used blank figures, or this is real figures that's coming out of the PV sol. And if that's the case, if a proper PV sol has been created, then you would use those figures in here. And again, it depends on whether you're doing the quote stage or the illustration stage. If you're just doing an illustration, then these numbers are far less important in a way. If you're doing a quote, they're much more important. So, and you will always have a PV sol anyway when you get to the quote stage, unless it's a tender. Slightly different in that situation, of course it is. So again, there we go. I'm going to end the video at this point, and we're going to come on next to feasibility checklist.